Section 3. Fixed income and interest rate options. Here we examine various examples of options in use in practice, with a focus on the underlying asset being interest rates or debt instruments. Recorded purchasing call options is a bullish strategy, while purchasing put options is a bearish strategy. Therefore, with fixed income options, one buys puts to hedge against the rate rising and calls to hedge against the rate falling. The reason is that for fixed income options, the prices of the underlying debt instruments increase as the interest rate decreases, and vice versa. However, with yield-based interest rate options, the situation is reversed. One buys puts to hedge against the rate falling and calls to hedge against the rate rising. That is to say, with yield-based interest rate options, a call buyer anticipates that the interest rate will go up, whereas a put buyer anticipates that the rate will go down. First, let's consider options on Treasury bill. More precisely, consider a European option that expires at date T and is written on a T-bill with a maturity of M days when the option expires. The strike price of the option, denoted by small x, is a discount rate given in percentage, and the corresponding dollar price of which, denoted by capital X, can be calculated as follows. Note that the discount rate of a Treasury bill is an annualized rate following the actual over 360 convention. Let dm denote the date T dollar price of a Treasury bill maturing at date T plus M. Then the payoff of a call at expiry is dm minus x if dm is greater than x, otherwise it is 0. And the payoff of a put at the expiry is x minus dm if dm is less than x, otherwise it is 0. Next, we're going to introduce interest rate caps and floors. A cap or a floor is a series of interest rate options. An interest rate cap is a series of European call options, or the so-called caplets, on a specified reference rate, usually the LIBOR. The buyer of the cap receives money if on the expiry of any caplets, the reference rate exceeds the agreed strike rate of the cap, also known as cap rate. When used in conjunction with a floating rate loan on the same reference rate, a long position on the cap has the effect of limiting the effective interest rate paid for the loan to the cap rate. Similarly, an interest rate floor is a series of European put options or floorlets on a specified reference rate, usually the LIBOR. The buyer of the floor receives money if on the expiry of any of floorlets, the reference rate falls below the agreed strike rate of the floor, also known as floor rate. The writer of a floor pays the holder each time the reference rate is below the floor rate on each maturity date. When used in conjunction with a floating rate loan on the same reference rate, a short position on the floor has the effect of keeping the effective interest rate paid for the loan above the floor rate. An interest rate collar is a combination of a long position on the cap and a short position on the floor. With a collar, the interest cost of a floating rate debt is bounded between the floor rate and the cap rate. That is, when the reference rate rises above the cap rate, one is compensated by the cap seller. And when the reference rate dips below the floor rate, one has to pay the floor buyer. Here's an example. A firm issues a floating rate note paying 6 months LIBOR plus 90 basis points. The firm's financial situation cannot allow paying an annual rate beyond 11%. What financial instrument can the firm use to deal with the rate limit problem? since a long position on a cap has the effect of limiting the effective interest rate paid for the loan to the cap rate. The firm could purchase an interest rate cap with a cap rate of 10.1%, and with the 6-month LIBOR being the reference rate. Interest rates on actual over 360-day count convention are often used in the specification of interest rate derivatives. In the case of a cap, the payoff at the expiration of a caplet is given by the following formula, where X is the cap rate and R is the M-day interest rate. Both rates are on actual over 360-day count convention. Thus, the first three terms of the formula gives the amount of interest to be received by the cap holder on an M-day deposit of a notional principal N. Hence, to obtain the payoff at expiration of a caplet, one has to multiply it by the discount factor for the M-day period. Similarly, for a floor with floor rate X, the payoff at the expiry of a floorlet is given by the following formula. As mentioned earlier, the payoffs for both caplet and floorlet are discounted because they are received at the maturity of the underlying, which is M days from the caplet or floorlet's expiration date. For example, consider a 6-month European call on a 6-month LIBOR, equivalently 182 days, with a 7% strike rate. The face value is $10 million, and the expiration date is 6 months from now, equivalently 183 days. Can you determine the payoff of this option? This call option gives the buyer the right to receive the following amount at the end of 182-day forward period, where R is the 6-month LIBOR prevailing at the option expiry, which is 183 days from now. From the timeline, it is clear to see that the cash flow V to be received at the maturity of the 6-month LIBOR is 182 days from the call expiration and is 365 days from now. Therefore, the value V at the expiration of the call is given by the following expression, where we use the prevailing 6-month LIBOR R for the discounting purposes. As a summary, in this lesson, we have studied the option on Treasury bill and the interest rate caps and floors. In particular, the evaluation of the payoffs of the caplets and floorlets. Next lesson, we will wrap up the caps and floors and introduce the options on interest rate futures.